Hello, welcome to this session on C+ version 2020. This new version allows very interesting feature to increase productivity when constructing models. Here, a ship model, or fraction of it. And for this model, we work in the 3D geometry where we have imported the finite element model. Then from the display PID, which are here, we have created shapes, for example, plate shape here, check all. And from this shape, we have created the subsystem by the ball here and display here. The first task for us will be to generate all these junctions. They are still generated here. What we do is to delete them. Globally, we can delete all junction. Okay. We show how to generate them from scratch. Second task is to redo the junction. We have also beam to structure junction. Delete also that one. And now we have the model without any junction there. Okay, and I can shrink this model, show you the various panel. And now at this stage, we want to couple everything together in an automatic way. And for that, we have to set up the auto-coupling routine. And this routine can be set from the geometry option panel in the tab SE object with two methods typically. First, the fastest one is coupling the subsystem by their contour node. We just scroll the contour node, and so it's faster than to scroll all nodes. But sometimes there is subsystems which are not coupled on the contour. For the coupling, we have to uncouple use contour node. And if there is common node, there will be found in the interior of the subsystem domain. Even if some systems are totally uncoupled, because connection between nodes are not present, we can define a ball diameter. Typically here I put 0.1 meter because it's a large ship. And using this diameter, we can consider that all nodes within this distance will be coupled together. And to refine a bit, if the junction have different distance between the expected coupled node, we can identify the minimum distance between this node and put some coefficient here to define a range of distance in which the node will be considered as coupled. All right, so for the moment I will use this contour node, so I check this parameter and then I click OK. And for the coupling, you just have to click on this button at the right corner, top corner of the palette subsystem, and using the right button of the mouse, you check all, in fact. I click OK, and then the routine start. It runs till it finished. As you can see, the auto-connect function has well progressed. For the moment, there is about 890 junctions that have been found. 900 now. You can see on the model that substructuration, of course, is not individual FE, but more or less based on distribution of material properties. So some part of the hull are very large, some others small, depending on presence of discontinuities and based on their physical section property. So here we are. The software has done the job of detecting the junction. 1126 junction created. 16 beam structure junction. We can close the routine. And we can see the found skeleton of junction. Clicking on some particular junction will open the dialog property, and we see here it was detected as a line with angle between plate and junction lengths. And if I click on this point here, you have detected multi-point junction with a connection length of 3.2 meter and 90-degree angle as well between the connected panel. All right, the work is not finished because it may be there could be some junction not detected, anterior junction, now have to be detected. In the second step, I click back on geometry option, unclick use contour node, okay, and rerun again, check all the autocoupling function. And now it started detecting remaining junction by scrolling all subsystem nodes in order to find out if there is some internal connection between subsystems. He skipped most of the junction because they are already coupled. The total duration of the detection is about 10 minutes. It's obviously depending on the computer. This is a notebook, so it's not so fast than on a standard PC. So 7 new junction created. Okay, I close it. The skeleton of junction has not changed much because it's difficult to detect extra junction created. So if I display the subsystem again, okay, you have the model. And now this model is ready for use. Huh? So you have just to export it to a C+ page in order to add extra load to the model. Here we are. So the model has been built into the 3D user interface. What you in yellow, it's the original FEM from which it is created. Now we can add some source. I've already done the job in this model, so you can see this model with I put some power, 1 Newton power on all wave, unit power on all kind of wave, flexural shear, extensional, just to make a solve. And then it will solve this problem, and we just look if the model seems okay regarding energy distribution. The first time C+ solve the model, you have to calculate all the junction. As soon as the junction have been calculated, the loss matrix being built, generally if you change parameters that does not require interaction between subsystems, like the power and the damping loss factor, the SCA matrix is not rebuilt or locally rebuilt depending on modification, and the second solve is generally much faster, a few seconds. In that case, it takes times because we have to scroll all subsystems, compute all modal densities and all mobilities and so on, all SCA parameter, and then here is entering in the processing of coupling. So you see it's very fast on the bottom and full line, because junction calculation is highly parallelized. Now the solve is done, so what we can do is just to display a thermogram in order to see the energy distribution on this chip. 16 Hertz, and I will set to max per band in order to have the dynamic per band. If I go to 500 Hertz, I can see that the energy is concentrated where it is excited. It's more diffuse at low frequency, as you have seen. And if the dynamic is about 500 Hertz, 40 dB, something like this. If I go to highest frequency, let's say 10 kilo first. The dynamic is more than 60 with high radiation and high excitation of the hull. And above, in fact, the result will be similar. It's a very quick way to look if everything is connected, because if it should not, there will be very dark color subsystem in the loop. So everything is cross-connected and it seems pretty nice. Okay, thank you very much.